When we talk about the energy transition, we tend to circle around the same few topics: wind, solar, oil and gas, yes or no, or for how long. But beneath our feet lies a massive source of energy that not often makes it into the conversation. This episode is the first monthly deep dive of the season, a format designed to slow down, go a bit deeper, and build shared understanding across different perspectives in the energy transition. Today's deep dive is geothermal energy. And if you've been listening to this podcast for a while, you will remember me talking about this before Christmas. I was going to a conference organized by the Geothermal Energy Association of Norway, but I actually left that conference with quite a few questions and a feeling that this energy source needs lots more attention. So I invited someone who has been thinking about this for years. Stian Engebretsen works with production modeling and simulation and has a background in mathematics, fluid flow, and the complex realities of how energy systems actually function. When we met at the conference, it was obvious to me that he was quite passionate about this, and I knew he would be able to help me understand more. And just to be clear, I'm absolutely no expert in this, so I will be asking quite a few let's say beginner-friendly questions. Not stupid questions, beginner-friendly. We will look at what geothermal energy really is, what's happening in Norway right now, and what might be possible in the coming years. We'll focus mainly on Norway, but like most energy transition questions, what we discuss matters way beyond our borders. So with that, let's dive in, and I hope you learn as much as I did. One more thing, actually, we had a little sound issues when recording this, and I got to practice my sound engineering skills, which are not great when editing this episode. So you will hear that Stian's S's are a bit muffled, and that is not his fault. So just bear with us. I think you will understand everything that we're saying. Still, welcome, Stian.
Thank you.
And thank you so much for joining me for this first deep dive episode where we'll explore an energy form, a technology, or a solution that addresses the complex challenge of energy transition. And today we're focused on geothermal energy, and you are the expert, Stian. So maybe you can start by briefly introducing yourself.
Yes, thanks for the introduction already. I work as a product manager with process simulation, production modeling, and pretty much software development within the oil and gas industry, which has been the background and focus in that job. But over the later years, maybe since 2021, I got introduced to some customers wanting to simulate design and optimization of wells for geothermal energy. So I was curious and I got introduced to that industry, which is a cool industry about extracting heat from the subsurface. But now in these days, people try to do it in new ways and leverage it in different ways that is more scalable. So that's where I was introduced to geothermal. But
we'll get a lot back to the kind of the more technical stuff. But if you were now to explain geothermal energy to someone with no energy background at all, how would you do that? Where would you start?
Yeah, I guess I would start with, it's all, as you say, it's about the heat that's in the ground or thermal energy. And maybe focus on the two main use cases, I would say, which is about using that heat or thermal energy for heating or cooling purposes, or for electricity generation. So you can both use the heat in heat pumps in where you have heat conduction or heat exchange basically
Mm.
in wealth or in cables that you put in the ground, then it's more, you're actually using a form of solar energy. But the deeper you go, you get into the real geothermal and the temperature that, coming off the earth. I think it's a hot ball that we're
Mm.
flying on. Um, then there's also the part of using and producing the water that you have in the reservoirs and using that heat directly, like in district heating. And finally, for the really hot places on the earth where you have like geysers and hot sources, or if you drill deep enough, you have resources where you can produce steam or really hot water and spin a turbine to generate electricity. But it has a lot of different modalities, but
Mm.
it's about using the energy that's in the ground.
So, we're talking about Norway, and this is how we met at this conference, which was focused on geothermal energy in Norway. Um, how is it like? What is actually happening in Norway today when it comes to geothermal, and what is also, if you could add that, what is special in Norway about our geology?
I guess, yeah, Norway is like other Scandinavian countries, it's cold here, right? So we need a
Mm.
lot of heat, a lot, but especially in Norway, we use electricity to heat our homes. Um, but the geology of Norway is such that it's not necessarily, really hot in the ground. You don't have a high geothermal gradient
Mm.
as you have some other places, like Iceland. There's volcanism, you can use and create electricity generation. There's none of that in Norway. Uh, so we have lower temperature in the ground, but it's a really hard bedrock. So when you get down to the bedrock, it's granite and gneiss. I don't know what's that in English.
Me neither.
Um, but that favors, for example, borehole heat exchangers. So in
Mm.
Norway, there's a lot of, well, medium, or what we call shallow and geothermal wealth, from 100 or 50 to maybe 500 typically meters deep. And you exchange heat with the rocks, basically. And then there's also cracks there's a lot of crack and water in the bedrock, which is a good way of doing that kind of geothermal because you have a stable heat source or temperature in the ground.
Mm.
That means you can have heat pumps designed optimally, and they work constantly, for example, heating individual homes, uh, because you have that stable temperature all the year around. And you also get cooling in the summer. Unlike air-to-air heat pumps, for example,
Mm.
where the efficiency will vary a lot more. So there's a lot of that. And then there's increasingly bigger systems designed for, not industrial use, but I would say, office buildings and such, where you just build a lot of or drill a lot of well underneath before you erect the building, and then there's always also some new technologies there, which we have seen, which is called geothermal, which
Yes.
basically is a higher temperature. Um, is for storing energy as well, right? So you
Yeah.
can operate at a high temperature, like 40, 50 degrees in the ground. You heat a block of wells in a concentric circle. You drill a lot of wells, and you heat it while you cool in the summer. That charges the ground with heat, and you can use that for the heating purpose in the winter.
Yes. So can you talk a little bit more about that? The geothermals. That was the first time I heard about that actually at this conference. So
Mm.
what is the difference then, and kind of what is the potential for that? For instance, somebody talked about it in related to the big data centers and for storing, like combining that with also storing heat from that.
Mm.
Is that correct?
Yeah. So it when you have heating and a cooling load, and you have that in Norway, especially in the winter, you want the heat. So
Mm,
most private buildings, it is mostly a heating demand, right? Through the
yes.
winter and cold period. But like office buildings, you have more of a cooling demand as well. So when you cool, you flip the heat pump, and then you can discharge that heat, which you take from the air in the building. You can discharge that into those wells.
Yeah.
And then that like is a storage, is storing that energy for using in the winter. But then you can also use heat from the sun and
Mm-hmm.
also use that to charge, put it into the ground in those wells. And then potentially also other energy sources of heat, what to call it, heat, waste heat from, for example, industry or data centers.
Yeah. So you can actually combine many different or multiple energy sources into these, like the thermos,
Yeah, so
right?
it's like a symbiotic
Mm,
thing, right? Where you increase efficiency of like a total system while combining different
yeah.
things. That's like one of the things we should do maybe as a society is plan out how we orient our society, right? And
Mm,
this is one way of increasing the efficiency of our energy systems, I guess.
yeah. So you talked a little bit about what's special about Norway and that it's not it's cold and we have this hard bedrock. So how does that influence the cost? Because my next question was actually how what is the biggest reason that it's not scaling faster, for instance, in Norway? So is that the cost? Is that the biggest reason, would you say?
I don't know. I don't really know that kind of market in Norway, especially really well. But I think part of it is other things are more dominant in the collective mind of people, I think. And
Mm,
when you talk about misconceptions also about geothermal, I think the more problem is like people don't know about it. And
yes,
it can
yeah,
be a bit technical to
yeah.
understand it, right? The different sides of it. But yes, a part of it is about the capital expenditure up front of systems. Uh, but these big systems for big buildings and what's it called, like schools and apartment buildings, it
Mm,
really makes sense when you look at bigger systems, and it's gonna pay itself off. The resource itself, the wells you drill, they last for many decades, especially when you get into these periods of expensive uh, power or
yeah.
electricity, and we heat everything with electricity in Norway, then it definitely makes sense. But I think also, you need the incentive from the government potentially as well. Right? We're talking about improving the grid, right? Expanding capacity, but these are technologies that lowering the need for doing that. So when somebody
Mm,
installs that kind of heat pump, you smoothening out the peak loads. Your house, for example, is not gonna need that peak load because
mm,
it's stable way, and also you get free energy from the earth. So I would say it's complex, but you need the economy of such system, at least for bigger building. It's good, and
mm,
it's also good for the society. So the people installing it is doing society a favor, where
yeah.
the society should perhaps be
More supportive.
trying to ramp it up, I think.
Yeah, and another thing I heard about was the need to get more decentralized energy systems, like for preparedness, for instance, and not being having to rely on one big kind of hub for the energy system, right? Isn't that also
Yeah,
a reason?
and that's also another point, right? And especially when it comes to electricity generation, which is not the case in Norway as of now. Could be in the future in as technology improves, but like you have the United States Army and Navy and different bases looking at, you're drilling well, you're able to produce power. You can also do it without the need of grid electricity. You need some electricity to drive a plant, but these technologies can also be started from potentially from cold condition because they can drive themselves to some extent. There's a
Yeah.
lot of cool aspect in that
Yes.
regard as well.
Yeah. So with your work, when you work with modeling and simulation, can you explain a little bit about how that works and why does that matter so much for geothermal?
Yeah, it's like in oil and gas, it's capital intensive upfront. So you're doing a lot of planning of the project. You're citing your resource that is gonna, and then you're spending a lot of time understanding that resource, defining the system that's gonna extract energy or petroleum or which is then is gonna produce money down the line, right? So and and for geothermal, you since you're spending so much money oil and gas as well, you need a good understanding of how it's going to go, and you need to understand the uncertainty, right?
Yeah.
Low and high case of getting a return on that investment. So delineating, making models, understanding how big of a system or a power plant, what the capacity needed, and how big is the system going to be. You need to have an understanding of that. So that's
Yeah.
where modeling comes into the picture, both for just designing what to build, but also having some estimates on the risk and the economic potential of that project.
So when working with this and you have for some years, how have you seen, like, for the maybe 5, 10 last years, the technology of geothermal? Like, how has it improved during the last few years, perhaps?
No, it's improved rapidly, I would say. It's taking, knowledge from the oil and gas and applying that, and especially on, of course, on materials and drilling technology. Um, take the fact that you can drill very long and horizontal well, that has, triggered what's called enhanced geothermal systems, where you drill deep enough, then it's heat everywhere. But there's not reservoirs with hot water in the ground everywhere. So that's one technology where you can drill. You can then fracture the rock between an injector well and a producer, and get the water to go from one well and into the other. So that's technology pretty much coming from oil and gas. But the geothermal industry has gotten funding, a lot of funding, to do the project now, and they have proven themselves to be able to do it, and that's exciting because it makes it now possible to scale this to not just the hot regions of the world where there's a reservoir that's being possible to produce from. You can now do this in more locations. But yeah, these companies have really increased the drilling rate, right? So they drill way faster now. In just a couple of 5 years or something. They're gone from 8 meters per hour to like 30 meters per hour and also in hard rocks.
And that has a lot to do with like for the cost, right?
Yeah.
Yeah, the
Yeah, so
speed.
the wells are a big part of the cost when you drill. It costs a lot to drill. It also costs a lot to complete and cement and make the wells ready to produce. And also, of course, the power plant, if you're making electricity on this, also costs a lot of money. So there's also innovation on
yeah.
that side. On the power plant, you're now able to produce electricity from lower temperature resources and what's called organic Rankine cycles, which is a Rankine cycle is basically what you do when you have you burn some fuel, for example, and you spin a turbine. So making steam or vapor to drive a turbine, that cycle, which is used in when you burn natural gas, is sort of what's happening in a nuclear plant as well. That cycle being adapted to work on lower temperatures means you're able to do this on colder resources
Right.
as well. And then what else? There's also just new methods. So a completely different concept is drilling like a radiator beneath the ground, which we saw in this conference in November.
Yeah.
This German use case
Yes.
of this Canadian company called Ever. They're drilling wells that go down and then into multiple arms,
Right.
and then up again. And they don't complete them. They are open whole well and just collect temperature, exchange temperature with the rocks, and you get heated water out. So a
So
lot of
that
different innovation.
so that is Germany, but what areas in the world would you say that is most like happening the fastest, perhaps? We heard a lot about Denmark, Germany, the US, I guess, as well. There's a lot happening, right?
It's been growing really rapidly the last years. So it's gone from 2017. The investment had grown 100-fold, right? And it went from like $1 billion in investment last year to $2.2 billion in investment into these new companies. Most of them are in the US.
Right.
And still after, I guess Trump cracked down a bit on new energies, I guess, in the US, but geothermal is still, a place where a lot of companies are putting money in and technology. So I would say definitely the US is leader, but then there's also countries like New Zealand, some among the biggest traditional geothermal countries, I would say, are putting money into this and also researching the use of super hot rocks, which is if you drill deeper, if you get into super critical conditions, that's it's called, then you get way more efficiency out of the system. So that's sort of like the holy grail, right? If you're able to produce, you can tenfold the energy from a single well, for example, if you get up into those temperatures. So, but that's a bit more down the line, but research is going on. But like Sintef in Norway, actually, we talked to Magnus at the conference. He was the part of drilling the hottest well in Larderello in Italy. So there's a lot of difficulties when drilling hot wells, like on the sensors, on the drilling and on the testing of the wells. So he was a specialist in like making temperature sensors and pressure sensors. So that was a 500-degree well. So Norway as well, we have a lot of technology. I would really like to see that technology being leveraged to do this, even though Norway now isn't like a geothermal powerhouse for electricity generation. It could lead the technologies that get us there, right?
Yes. And that
But
technology mainly comes from oil and gas, right?
yeah,
Or
I
yeah.
mean that's where it's been developed.
Mm,
High temperature, pressure, and high, for deep water and stuff like that. But it's pushing the envelope way further when you get into geothermal, of course. So you have a
mm.
lot of, you need to innovate that even further.
But when you said did you call it supercritical rocks or something?
Yeah, super
Yes,
critical conditions.
conditions. What does that mean?
So super critical, that's like a physics expression.
Term.
I mean,
Okay.
it means that when you have a fluid, it can be solid, right? The water can be solid, it can be
Yeah.
ice, it can be liquid, and it can be gas, or it can be in a supercritical state above its critical point.
Oh.
And that's where there's a critical point in temperature and pressure. Above those, either in temperature or above that pressure point,
Mm-hmm.
then it behaves not like a gas or liquid,
Mm.
but it's its own state, but it carries way more. It's more energy dense,
Right.
so it's carrying more energy with it if you transport that water at that temperature to the surface. You get way more energy out of it.
Interesting. Huh. So there's a lot of potential. But so looking ahead now into the future, what do you think is realistic? And you can think about Norway, but you can also think globally, like when it comes to geothermal and the development.
I think in Norway, it's proven that you make efficient systems like these geothermals we talked about.
Mm,
It's great. It's being done now, and there's probably ways of operating and optimizing the production or how it's used, right? You can decide if you want to take electricity from the grid to heat your well in the summer. You can optimize its operation,
mm,
and they already have like system performance factors, which is the average performance factor throughout the whole year of 4.6, which means you spend 1 kilowatt hour, you get 4.6 kilowatt hour of heat into your system.
right.
And that's on the average. So that's really good. And that is going to save them the project and, of course, the society, because you get that free energy from the ground into your systems. And that's 70% of, homes energy is in heating and hot water and heating of the house, more than that. And it's, I don't know, is it 50% of in the society or something goes to heating.
Yeah.
So it's going to continue on that, but then also, of course, innovation happen at different layers. You have somebody working on super hot down the line, somebody working on just improving what's already working, and somebody working on, what's going to work in 5 years. So the really interesting thing on a global scene is happening in the States right now with EGS, where they make reservoirs where there's
EGS,
no
that
reservoir.
is enhanced geothermal
Yeah.
systems. Yeah.
And I just saw on LinkedIn now they drilled a 290-degree well in such a system now, which is really hot. So they are, going towards super critical, I would say. It's a long way there because there's a lot of complexities when you go into that temperature range, but it's moving along. And then this company in Germany, the first of its kind. The real question there is, can you produce energy, keep it sustaining? But there's different risks and places and timing for these systems, right? The stuff in the US on EGS, that carries risks of seismicity.
Right. Yes.
So you don't want to use that technology in the center of Europe in some urban areas with a lot of
Yeah.
people.
Exactly. And
That's
that is
where
a
other
question.
technology is getting.
Yes, and that is a question I've had sometimes. What about that? Because that is something people heard about, induced seismicity. What is the risk of that?
And there is a risk. So all of the research, it started like in the 70s, some of the first EGS attempts. And when you frack and you inject water into those fractures, there's induced seismicity, basically. But the significance of it, how big it is, and that's the important part, I guess. But all of these projects are inducing seismicity, and some have come up to 5 on the Richter scale, and then the project is canceled.
Yes.
So that's why they are testing new technology in Utah, and Nevada,
In the desert, and yes, right. Because I guess it doesn't take a lot to shift the ground if you're in an urban area, and that can have really bad consequences.
Yeah, and you can activate fault lines,
Right.
and that you're not aware of. Beneath the ground, it's all uncertainty, right?
Yes. Yeah. Exactly.
But the Danish company you mentioned, right, which was at this conference, which is all about drilling a well and completing it with a casing, meaning no fluid is going in or out of the reservoir. Then you take away that seismicity risk, and it becomes. That's why it's interesting for Europe, I think, and why they see pilot projects in Denmark and Europe on that. It's a technology which you call closed loop borehole heat exchange, but it's also relevant for hot reservoirs. So the geothermal operators, they drill wells which doesn't produce water. So instead of just throwing that well away, you can complete it and circulate water within it, and get energy from that as well. So
Yeah.
but
And
but
that
the,
well doesn't have any kind of contact with the surroundings, right? That is the point with that
it
closed
has the
loop system.
contact, uh, thermal contact, basically, right? You just
Right.
extract
Yes.
heat
Yeah.
that's conducted. Well, what we call conventional geothermal, how these power plants are made now, they take water from a reservoir. They get water from the rocks into the well and produce it, and then they inject water again. But so that has seismicity risks with it.
Yeah.
But there are now different ways of doing this without producing that water, just circulating, for example, water. You can also circulate other things like supercritical CO2, for example. It never gets out of the loop. It's just circulating, and that improves efficiency.
Right. Interesting. So, so there's so much, and we could get really really technical, I guess, but we won't. So, but for my listeners, who should be paying attention to this? Like, even though you're not working in geothermal or even in with energy at all, but how should people be more aware, and maybe how could the public's perception of this help scale it, would you say?
Yeah, I think that is key. You know, how these decisions are made, it's above my head, but I really do think a lot of stuff can be happen on with people's support and will. So I think people need to know about it, but why should people care? I think it is really simple. So these technologies that I have briefly mentioned, like ORC, organic rankine cycle, as a closed system, it can be made fully emission free in operation, right? So some geothermal plants, they release gases, because they are associated with geysers, right? So you have
Yeah.
geysers that anyway is releasing stuff into the atmosphere. But if you're just using gas directly coming out of the ground and you're releasing that gas afterwards, that's not a closed system. We are now able to make closed systems, so they are emission free. They don't use rare earth metals. Typically, you make a power plant, you know, out of steel and metal and stuff like that. So that's good. For the environment, it's not land intensive, you know,
Yes.
not use a big area. So you
Right.
build a power plant, you have some wealth here and there, but it's not like solar where you need to really have some considerable acres or area. That's environmentally speaking, but there's also, it's really good for the grid, for example, right? You need a certain amount of base load energy. I mean, energy sources that are stable, which don't fluctuate like this. You're able to regulate them. They are flexible, that you can ramp them up and down to a certain extent. But, you know, for critical infrastructure in hospitals, every society needs a base load amount of energy that's stable, and industry likes that. That's something with geothermal. You also see that people are paying power purchase agreements. So data centers, we want this, you know, because they cannot deal with this type of intermittent energy. They need a certain fixed amount of energy guaranteed, and that geothermal can provide that in those areas. And Aspen Technology matures, I think we're going to see more of that. I mean, Google and Meta are already into projects aiming for these PPA, power purchase agreements. So just as a person that cares about the environment and which doing smart things in the energy systems, I would say that's why people would like to do more of it.
Yeah. Yes, exactly. Yeah, and we have talked about this before, like the maybe the awareness marketing, or like talking about it, and people like hearing about it, because it's not very easy today to find like information about it or what is happening. I don't think so, at least.
No.
It's kind of hidden still. So we need to do something about that, I think.
Yeah. So that's my aim. I try
Yeah.
to be more visible and talk about it. I think it, it's great. More people should learn about it, and but we are seeing more of it. That's the
Yes.
good thing, right? Since I followed this since 2021, as I said, the investment have grown 100-fold. So I think it's coming.
Yes. Let's end with that very positive note. And thank you so much for your time and sharing your expertise. That it has been great, and the very first in this series of deep dives into an energy form or technology. So really, I really appreciate it. So what do we take away from this? Geothermal energy might not be the loudest voice in the energy transition conversation. It does not dominate headlines, that's for sure. But it doesn't trigger culture wars either, and that's a good thing. And it's steady, it's technically sophisticated, it builds on decades of subsurface knowledge, and in the right places it could play a much bigger role than we currently see. For Norway, that might mean smarter heating systems, more efficient buildings, and perhaps in time, technologies that we help develop, even if we don't become a geothermal electricity giant ourselves. And globally, it's clearly moving. Investment is growing, innovation is accelerating, and the underground is becoming very interesting. So this was the first monthly deep dive of the season. Each month, we'll slow down and explore one energy form or technology, not to oversimplify, not to take sides, but to understand what's actually possible. If this episode sparked new questions for you, I would really like to hear from you. You'll find links to Stian's work and the Geothermal Energy Association of Norway in the show notes. And if you'd like to continue these conversations beyond the podcast, you can join me on Substack at viklamnes.substack.com or on my website storiesforthefuture.com. Thank you so much for listening. Until next time, stay curious, and I will be back soon.